Hello, so this video is here to explain the joke that you may have seen on the interwebs claiming that what appears to be that October 31 equals December 25. So the key with this joke is understanding a little bit about modular arithmetic, which normally you don't delve into very deeply unless you've taken some kind of computer programming course. Now, what really is happening here is that the claim that's being stated is not actually about calendar dates at all. It is actually a statement that two different representations of a number are the same. So you actually know a little bit about modular arithmetic, even though you don't necessarily think about it explicitly that way because you probably don't even know. So you actually use modular arithmetic whenever you read a clock. As long as you're not in military time, the idea is once you get past 12 o'clock, then you start counting again at 1. And that's how our number system works when it's represented in decimal notation. So we'll start here by reminding ourselves what is decimal notation. So what we think is December here is actually representing the decimal representation of 25, which is just the number 25 that we know and love. So what do the 2 and the 5 actually represent here? So let's remind ourselves a little bit about place value. We have the ones place value, and then we have the tens place value. And the way our numbers work is once we have more than 9 of anything in any given place value, then we create a group of 10 and move over to the next place value. So I'll demonstrate that by actually building the decimal representation of 25 one by one. So I start with 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I were to write the number 9 here, then I can't add one more to that and still stay in that place value. What we do is once we throw one more on, then we actually have one group of 10. So we'll move this group of 10 over into the tens place. And moving on, we'll continue. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I have 19 of my 25, which means that I have an additional group of 10. So now I have two groups of 10. So that's why we write the number 2, because my groups of 10 here, I have 2 of them. So I have 2 groups of 10. All right, and then I have 5 more 1s. So 1, 2, 3, 4, 5. So you can see the 2, you can see the 5. So I have 2 groups of 10 and 5 groups of 1. So as it turns out, October 31 doesn't mean October 31 at all. It means 3-1 in the octal number representation. Octal meaning 8. So another way that this number would be represented, or the way we would read it, is as 3-1 base 8. We don't say 31 because 30 really means 3 tens as we say the number in our decimal number system. So to help us understand that this 3 doesn't represent groups of 10, we either have to indicate that it's an octal number, or we'll write a 8 here, but we also say it as 3-1 base 8 so as not to confuse ourselves. So how does the octal system work? Well, it's very similar to what we did over here, only instead of a ones and a tens place, we have a ones and an eights place. So this time, once I have a group of 8, then I have to move over to the next place value. So the 3 here means that I have 3 groups of 8 and 1 group of 1. So what does that look like if I represent this number? Well, if I have 3 groups of 8, there's my 3 groups of 8, and then I'm going to have 1 group of 1. So what we'll do next is actually show that the number 3, 1 base 8 is the same as the decimal representation 25. So let's try this out. So I have 1 here, so we'll go ahead and check off 1 over here, and then we have a group of 8. So 1, 2, 3, 4, 5, 6, 7, 8. So I'll go ahead and cross off 8 more over here in our decimal representation. So 1, 2, 3, 4, 5, 6, 7, 8. And then we have another group of 8. So far we've accounted for 9 of our 25. So now we're going to look at 8 more. So 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. If you already see it, you can see that we have 8 more left. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 3, 1 base 8 is the same number that we represent in our decimal system as 25. It's just a different representation, a different organization, looking at 3 groups of 8. That is 3 times 8 is 24 plus 1 is 25. So that's a little bit about modular arithmetic. In fact, if you've seen the movie The Martian, then you saw Matt Damon communicate with back with Earth to help them know that he was alive using the hexadecimal system. So that is 16 characters. So basically being able to communicate by using more symbols than we have in our decimal system, which is 10, but fewer symbols than we have in our alphabet, which has 26. Our computers work in base 2. A lot of the time, a lot of the kind of machine language behind the scenes is all working using 1s and 0s to represent groups of either 0 or 1, and a place value system where the groups are groups of 2 instead of groups of 10 or groups of 8 or groups of 16 like we would have in other bases. So if you want to learn a little bit more, go ahead and look up a little bit, search about modular arithmetic on the interwebs, take an intro to computer programming class. There's lots of fun things that you can do with different number representations. I hope this was helpful. Take care and enjoy.